We are live. Hi everyone, welcome back to Code Era. Today in this video we will discuss the LeetCode daily challenge for 29th of December. The problem name is populating next right pointers in each node. This problem has been previously asked in organizations like Google, Microsoft, Amazon and Adobe and many other companies like these. So just consider giving me a quick +1 in the chat if everyone is able to hear my voice and my screen is also clearly visible, and then we'll start with this session. So this problem is rated as medium, and for someone who is targeting product based companies in which there is a high probability that they will be asking you problems related to trees, binary trees and things like these. So this problem is one that you should be doing beforehand. And just quickly consider giving me a +1 in the chat if everyone is able to hear me out, and then I'll begin with today's session. So in this session I'll be discussing with you three approaches for doing the same problem. The first approach that I'll be discussing will be using level order traversal. The second will also be using level order traversal, just a slight change would be there. And the third approach that I'll be discussing with you guys would be based upon recursion, right? So all those who have joined this stream, just quickly consider giving me a quick +1 in the chat so that we can begin ahead with today's session. I'll just wait for a couple of minutes for everyone else to join in, and then I'll start with the explanation for this problem. Basically, this problem says that you have been given a binary tree, perfect binary tree. What do I mean by a perfect binary tree? I'll let you know. And where the leaves are on the same level, all the leaves are on the same level, and every parent has two children, right? And what you have to do is you have to populate each next to its next right node, right? If there is no right node, then you have to point it to null. So initially all the pointers are set to null as well. This is also something that has been mentioned. So all those who have joined this chat, please consider who have joined this live stream, please consider giving me a quick +1 in the chat so that we can begin ahead with this problem. So let's say if you have been given this binary tree, right? What do I mean by a complete binary tree or a full binary tree, right? This is mentioned perfect binary tree. What do I mean by that? If there is a perfect binary tree, so that means that if this is a parent, so for this parent there will be two children, right? This will have a children, this and this, it will have both the children, right? If this parent is having children, so it will have both left and right children. This parent will also have both left and right children. So if a level, if on a level we talk about it, so on a level basis, every level is completely filled, right? Like in this level you can have two nodes and you are having two nodes, right? In this level you can have four nodes and you are having four nodes. Notice that if there is a parent who is not having any node, so other parents are also not having any node, right, on that same level. So basically that means that all the leaf nodes are on the same level, right? Is this much part clear to everyone? Just quickly consider giving me a +1 in the chat so that I know that this much part is clear to everyone, right? Now next up there comes a question like how will we actually be implementing this part? So what we can do is, you can notice one thing, that for this one I can say that I should be pointing it to null, right? I should be pointing it to null because the right node towards it is what? The right node is not, there is no right node, so that is why it should point to null. For this 2 there is a right node, so I'll point for this current node, its next will be pointing to this 3, right? And similarly for this 3 there is no right node existing, so that is why I'll point it to null. By default it is actually pointed to null only. And this 4, its right child is what? Its right child is 5, right? Towards its right there is a node that is 5, so that is why I'll point it to 5. I point 4 to 5, I point 5 to 6, I point 6 to 7, and then 7 will point to null because there is no child available in it, right? There is no child available for it. Now these are the conditions that you need to keep a check on. Now there comes a question like how will you actually implement this problem? So if you see, there is nothing difficult in this. It is basically, you can do this problem using level order traversal, and that will be very intuitive. Level order traversal using a BFS, is something that we can do. How we can do that? Level order traversal using BFS, that is by using queue, right? By using a queue we can do this problem. How? So first of all, at whichever level you are, what you can basically do is, let's say you are at this level, right? So first of all, you insert this node, this first node into your queue, and once you have done that, so you check what is the size of the current, right? So let me write a little bit of pseudo code for it. What I am basically saying is that what you will be doing is, you will say that while you are not of queue.empty, so unless and until, you will first of all be pushing one into your queue, right? Once you push your one into your queue, so what happens next is, you will check if your queue is not empty. So in that case, what you will do is, your current node is what? Your current node is queue.front, right? And after that, you pop this out. And before doing that, you also do one thing, that is you find out this size, right? You find out this size, whatever is the size, up till that many number of times you will be running your loop. How? I will let you know. Like, what in this case, what you will be doing is, let's say for this case there is only one level, right? So since there is only one node, so that is why I'll point it to null, right? If there are two nodes in this level, so I know that there are two nodes, right? So after one, I'll push 2 and 3, right, into the queue. So I have 2 and 3, so I know that at this particular level, before traversing for this particular level, I'll be knowing that what are the total number of nodes for this level, right? So the total number of nodes for this level are 2, right? So if I have 2 nodes on this level, so I know that this 2 will be pointing to this 3, right? This 2 will be pointing to this 3, but this 3 will be pointing to null. So that means the second node will on this level will be pointing to null, right? Now after that, I have 4 nodes in this, right? In the last level, I have 4 nodes. So I can say that the fourth node will be pointing to null, right? So in this way, how I'll be actually doing it, let me show you a little bit of code for that. So what I'm basically doing is, if my root is null, then I'll simply return null, right? This is a base condition that I need to check. After that, I declare a queue, and in that queue I push my root. If my queue is not empty, until that time I'll be doing the traversal. That means until and unless I do not have any nodes left, I'll be doing the traversals. So I'll be storing the size for a particular traversal, for a particular level that I am doing. I'll be storing all the number of nodes that are present there, and I'll iterate from I is equal to 0 and less than I is less than size, and my current item or my current node will be queue.front, right? If my size minus 1, that is n minus 1, is equal to I, since we had I is running from 0 up till size, so that means for this node, that means for, let's say for this particular node, size minus 1 is what? 3, right? For this particular node, if you consider 0 based indexing, so this is 0, this is 1, this is 2, this is 3. So in the 0 based indexing, this is 3, this is the third node, right? So that is why what will happen, you mark it as 3, and you keep on checking your, that is this, the size is 4, so size minus 1 is 3, and I will also be 3. So if I is equal to n minus 1, I is equal to size minus 1, in that case you will be pointing that particular node to null, right? This is what you are doing here. That is, if your size minus 1 is equal to I, so in that case, the current node that at which you are at, you mark its next as null, right? After that, you pop out the current node, you pop out the node, and if your size minus 1 is not equal to I, right, if you are not at your last node, then in that case what will you do? If you are not at your last node, so in that case you will say that your current node will point to which node? If you are not at your last node, let's suppose that you were at this node, right? If you are at this 2, so you have popped this 2 out. Notice that you have popped this 2 out, right? So now earlier you had 2 and 3, but once you come to 2, you have checked that it is not the last node, so you have popped it out already. So now what is at the front of the queue? At the front of the queue I have 3, right? At the front of the queue I have this number 3, I have this node 3. So what I'll do, I'll say that my current item, that current node that I am having, its next will be equal to what? Queue.front. If let's say I am at 4, I have this 4, 5, 6 and 7. So if I am at 5, so that will mean that in the queue there is stored 6 and 7. So if this is my current node, so current next will be pointing to what? Current next is equal to nothing but queue.front, right? Queue.front will be the next node towards the right that I will be requiring, right? That is why queue will be helping me out in this case, right? If this much part is clear, please consider giving me a quick +1 in the chat. if this particular explanation is clear, and then I'll be moving on to the second and the third approach for this same problem. Just give me a plus one if this much part is clear. What I was basically saying, if there is 4, 5, 6 and 7 suppose for a particular level, so I know that in my queue I'll be having 4, 5, 6 and 7. Once I come to this 4, so what I do, I'll pop this 4 out, right? And once I pop this 4 out, so I'll assume that these are not connected currently, but they are on the same level, right? So what will happen in this case is, I will say that my current, this is my current node, so my current next should point to what? My current next should point to q dot front. What is at my what is at the front of my queue? 5 is at the front of my queue, right? So I mark my 4 to 5, right? After that I'll move to this node, right? Now my current will be 5, so I pop out 5 from this, and what is the element which I have at the front of the queue? At the front of the queue I am having 6, so my 5 should point to 6. That is current next is equal to q dot front, right? After that 6 is pointing to 7, right? So I pop out 6, and then current next, that is 6 will 6 next will be what? 7, right? Right after that I empty I take out this node, and since this is my last node, so I'll say that it should be marking to null, right? In this way I'll be doing it in a level order traversal using a queue, right? Let me show you the code again and explain it to you. That is, if your size -1 is not equal to I, so that means if you are in the intermediate nodes, so you will be your current nodes next will be q dot front, right? And after that, since you know that you have to take all the left childs and right childs of the current node, so if the left child exists, so in that case you will push it into the queue. If the right child exists, then you will push it into the queue. If the left child doesn't exist, so that means the right child will also not exist, because this is a complete or a perfect binary tree, right? Now talking about this approach is very much clear, but the time complexity for this approach is okay. The time complexity is order of n, but the space complexity for this approach is something like, you can say order of k, that is the maximum number of nodes at the particular level, right? Or you can say order of n only, something like that. How can we optimize this space? Now if you are in an interview, so what the interviewer can ask is, that can you do this level order traversal? Can you do this level order traversal and do this without using queue, right? Without using queue. Can we do this without using a queue? Yes, we can do this level order traversal, that is marking it like that, without using a queue. How can we do that? So for that, you just need to notice one thing, that if you have 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to, let's say, 5, 5 is connected to 6, 6 is connected to 7, 7 this is 8, 9, then 10, let's say 11, let's say 12, let's say 13, let's say 14, this will be 15, right? Now next up, what is the condition here is, the condition that you need to notice a little bit in this case, that if you are at this node, let's suppose this is your current node, right? This is your current node. If this is my current node, so in that case what would be happening? I know that if this is my current node, then I have its left child, okay? So the current left is 8, and it should point to what? It should point to the right child. The current, if I am at 4, so its child is 8 and its child is 9. So its left child is 8, so I know that current node's left child should point to next pointer should point to 9. That means, can I say that current left next, for the current node's left child, its next should point to the current node's right child, okay? Like 8 should point to 9, right? This is how it should be doing. Like if there was 5, 10 and 11, so 5 if there was this 5 node, then its left child at this 10 should be pointing to this 11, right? Similarly, this 8 should be pointing to this 9, right? In this way, so I can safely say that my current left next pointer should be pointing to nothing but my current right, okay? This is one thing that you need to notice. Now another thing that you need to notice is that you can see now this levels will be done, but like if you are at this one, so it's 2 will be marking to this 3, right? 2 will mark to this 3. Notice that I am not using a BFS. I'll not using I'm using a level order reversal, but I'll not be using a queue. I'll show you in the code how am I doing this. So now this 4 points to this 5, but now this 5 should also point to this. Let's say you are at this 2. Let's say you are at this 2. So now for this 2, it's left child 2 is left child 2, which is left child for this 2, which is 4, is pointing to 5. But now this 5 should be pointing to this 6, right? 5 should be pointing to this 6. So can I say that my current write, the current write next node should be pointing to the current next node. What is the current next node? The current next node is nothing but 3, right? The current next node is nothing but 3. The current next node, what will be the next for 2? The next for 2 will be nothing but 3, and as we have already marked it, so the current next will be this, that is current next for 2, the next is 3. And what my 5 is pointing to what? My 5 should be pointing to this 6, right? So that means my current node is this. If 2 is my current node, supposing if my 2 is current node, then current's left child will next will point to its right. Perfect. But current's right child will point to this is my, if this is my current, then this is my current next. So current, if this is my current, then current's right child should next pointer should be pointing to current's next left child, right? Can you notice this? That 2 will be pointing to 5. 2 if 2 is there and 2 has a right child 5, so 5 should be pointing to the current next left child, right? 5 should be pointing to this current next left child, right? The next node on this particular level, that is beside, if 2 is the node, current node, then the next node for it is 3 and its left child, that is 6. So 5 should be pointing to the 6. That is why current right next should be pointing to current left, right? This is what I am saying. Now this comes in handy. Now there will be a situation like how will you write the code for this particular approach? That is the case. So I'll let you know like how you can write the code, or let me show you the code only so that you can understand it in a much better way. So what basically we'll be doing is, this approach will be very similar to the approach as we have discussed already, but in this there will be a little changes. Notice that there will be a previous node. Why there will be a previous node? Because you'll be using a previous node to store the previous node, right? What I am saying by, what do I mean by that? So basically I mean by that, what do I mean by that? So basically what I am saying is, if this is something, your tree looks like this, if your tree looks like this, then initially you'll mark your previous as this, right? You'll mark your previous as this, and then you will say that your current is equal to previous, and in this way you will be doing it. But notice one thing, that every time you are starting your iterations, so how it is being done, it will be depending on this, on these leftmost nodes of the particular levels. How? I'll be letting you know, but let's first read this code. What happens is, you mark your previous node to root, and current node you don't initialize it. Now you check if your previous node is not equal to null, right? If your previous node, let me copy this code and let's try to have a dry run with this code, right? Let's try and have a dry run with this code so that we can understand it much better. Let's say if this is the code, let me write the code here. Okay, now let's try and see what we'll be doing further. Okay, let me just copy this. Okay, so no problem, maybe we cannot do that right now, but what I'm basically saying is that my current that I'll mark my previous node, that is the previous. Let's suppose that if I am having a tree something like this, if my tree looks something like this, that is 1 is there, then sorry, that is 1 is there, and then towards is left I have what, 2 and 3, right? So how will I actually be doing this? I'll mark my current is equal to previous. Then if my current is not empty, if my current is not null, and I also need to check if my current left is also not null, right? If my current is not null and my current left is also not null, what do I mean by that? So if my current is not null, so that means if my 1 is not null and my 1, let's suppose if I am having the tree that is 1, then below 1 I am having this 2, right? Below 1 I am having this 2, right? 2 is connected here, and then towards the right let's say like this, I have my 3, right? I have 3 like this, like somewhere here. So if I have this thing, so if I have this thing, so I can say that this is, if this is my current node, that is 1, so I can safely say for this node that this is my current node. But notice that it is not having any next node, it is not having any next node, right? So that is why I'll not do the iteration for it. What I'll do instead is, what I'll do instead for this is, I'll say that the previous is equal to previous next left, previous is equal to previous left, right? What do I mean by that? So previous is equal to previous is what? Previous is previous left. So that means every time I'm moving, so I'll say that okay, for this particular node I don't need to do anything. This was my previous node, but now it should move to this level, right? It should move to the next level. So to move to the next level, I need to move to every time to the leftmost node of every level, right? I need to move to the leftmost node of every level. That is the starting node of every level. That is why I'm doing this. That is previous is equal to previous left. So that means whichever is the previous node, like let's say if this is the case, if let's say this is the case, like this, something like this. If I am at this node, let's say if this was my previous node, right, and I have done my work for this particular level, so in that case I should be moving to this node, right? I should move to this node because I'll be starting further from here. So that is why I'll say that previous is equal to previous left. That is why I am saying that after my this particular level is completed, then I'll move to this level. And how will I move to this level? Without using a queue, without using a queue data structure, I'll move it like this. Like my answer will always change like this, right? I need to move to the level, so I move to the first node of every level. How? I'll be storing the previous node. So currently, if suppose that this is my previous node, right? If this was my previous node, then there is no current node for it, right? So I will not do anything for this particular level. What I'll do is I'll move to the next. So now this is my previous node. Now this will be my previous node, and what will I do? I'll simply check if the left and the current node, that is the current node, that is this 2 and its left is existing. So I'll check. So with this 2, with this node, I can see that its left is also existing, right? So if its left child is also existing, so that means it is not the leaf node. It is we haven't come to the end, right? So I'll mark its left next is equal to current right. That means if this is my current node, right? If this is my current node, let me change the color. So if this is my current node, so I'll mark its left child to the its left child's next to the right child, right? It will point to this. And now what I'll be doing is I'll be checking if my current next is available. If my current next is available, so that means if I haven't reached for a particular level, if I haven't reached the last node of that particular level, so in that case I'll be marking its right. I'll be, if I, for this particular node, it current next is existing, right? So for this node I can say that its right child's next, that is current right child's next pointer will be what? Will be equal to nothing but this, that is current next left child, right? This is what we also discussed in BFS. But the thing is, this is the tricky part. Like previous is equal to previous left, that is how you are changing your levels each time, right? You can also split screen for dry run. Yes, I can do that, but don't worry. I hope that Ashoka, it is clear to you, and everyone else, please give me a +1 in the chat if this part is clear, right? Similarly, you will be doing for all the levels. Now let's suppose that you are at a particular level at which there doesn't exist this kind of situation. So in that case, what you will be doing, if the current is not having any left towards it, so that means that you have reached the leaf nodes, right? So for those, you must have already connected for them in the previous iteration, in the previous level, right? Like if you have reached this level, if you have reached this particular level, right, this particular level, if you have reached this particular level, so in that case this particular level is already complete, and in that case you don't need to do anything, right? This is how you will be doing it. Now let me show you the zoomed in code again, but I hope that the intuition and the dry run for this particular code was clear to all of you. Like while current and current left should exist, because only then I'll be doing the linking part for this particular level, that is the right pointer should be populated in this way. So if the current and the current left exist, so the current left will next pointer should point to the current's right, that is the right child. And if the next of this current exists, so that means my right child, the right of my the current child's right, should be pointing to the next child's next nodes, that is the adjacent nodes for 2, the adjacent nodes for 3, the 3 nodes left, right? The 3's left child should be where my right next should be pointing, right? I hope that this much part is clear. Now there comes a third way for doing it, and that way is pretty much intuitive, right? This is the best way possible, because in this way, like, you don't have to think very much how and why. The reason is, like, only the approach should be clear. The approach will be the same. Now what you have to do basically is, this is a recursive approach, that is the third approach. If your root is not null, if your root is null, so you return null simply, right? For a particular level, we are doing this recursively, right? If the root's left is existing, if the left child for a particular root, if the left child for the current node that you are at, if it exists, then you will mark its left child. Next, its left will be marking what? Its left will be marking the right. But perfect. Let me show you, like, how I am explaining it. What do I mean by that? So let's say you are at this particular level, right? If this is your current root, then if its left child is existing, so since it is a complete binary tree, so for this node, this is the current left, right? This is the current left. So current left's next pointer should point to what? Should point to this node, right? Should point to this particular node. So current next should be equal to what? Current left next is equal to current right. Okay, right child, towards the right child. Now this tree is also there, right? This tree is also there. Notice that, let's say it was 1 2 3, something like that. So now this was 4, this was 5, this was 6. So now this 5 should be pointing to this 6, right? So how will I do that? So I'll check if my right next exists. So that means if there is 3, that is, this is not the last node, because if this was 3, then its next would have been null. So if it is existing, so I'll say that my root's right child's next will be pointing to what? Will be pointing to nothing but root's next's left child, right? For this one, this part, like, its right child would be pointing to this 6, that is the root's next. This is the root next, and I'll be pointing it towards its you can say left child, root's next left child. This is how I'll be doing it. And after that, there's very simple part that you do. You simply push the after your iteration is done, like for the next, you check if the next is existing. So that means you will mark your root right child's next will be pointing to what? The next on the current root's next left, right? This is what I'm doing. Now connect, you'll call this function for recursively for the left child as well as the right child, and in this way you will be doing it like everywhere, right? Higher here you are pretty late, and then in the end you will simply return the root. So these are the 3 approaches with which we have discussed this problem. Let me give you a brief summary, like how we have discussed this problem. This was a pretty good problem. Like, I'll let you know, this problem was asked in companies like Google, Amazon, Microsoft, Adobe, and many other companies like that, like similar companies, you can understand. Now in approach one, you can if you want, I can also provide the timestamps. Also all the 3 approaches code is available for you. So in the approach one, what I was doing was, I was doing a level order traversal with BFS, right? Or you can say using BFS. I was doing a level order traversal using BFS. In the second approach, in the approach 2, what I was doing was, I was also doing a level order traversal for populating the right pointers, but let's say if the interviewer asks you that do the level order traversal without using queue. So for that, what we did, for that we stored a previous, and every time to move to the next level, you move to the leftmost, right? Previous is equal to previous left, right? In this way you keep on moving to the next level. So with using queue, okay, with using queue, and without using a queue, without using any data structure, we did this in order of one space, right? Without using any queue, right? Without using any queue data structure for doing the BFS part, right? Now the approach number 3, for the approach number 3, This was a simple recursive approach. The approach number 2 and 3 were very similar to each other. The only difference is that this will be implemented. This is something level order, and this is like we are moving in a recursive manner in this function. So that is the only difference. So is this problem clear to everyone? If this problem is clear to everyone, please consider giving me a quick +1 in the chat, so that I know that at least this particular problem is clear to everyone, and only then I'll be able to proceed further, right? Let me show you the code part for this, like what the actual problem says if someone has missed. So I'll let you know, like we had this 1, we had this 2. Let me write it here. Okay, if we have this 1, 2, 3, then 4, 5, 6 and 7. So what we had to do was this would be marking to this, then this would be marking to null, right? Then 4 would be pointing to 5, 5 would be pointing to 6, 6 would be pointing to 7, and 7 would be pointing to null. So in this way we had to do this. So like all the 3 codes I can show you, like if you do it using the BFS method, so if you have reached the last node of a particular level, then you mark it as null. Otherwise, if you haven't reached the last node of a particular level, then you simply mark its next as q.front. That is the next node at that particular level. For 5 you can mark it to 6. For 2 you can mark its next as 3, right? In this way. And for this you are also using a queue, so that is why you are taking extra space. But if you are doing it this way, so you check if the particular level has to be filled, that is you haven't, this means that if you haven't come to the last level, because the last level will the leaves will actually be completed. So you check if the current and the current left is existing, so the left child is existing, then you mark its left child to the right, its left child's next will point to right. And if the current next is existing, that means that the current node is not the last node of that particular level, so in that case its right child is also existing, so its right child's next will point to the current next child's left, right? For 3, for a node 2 which is having children 4 and 5, so 5 will be pointing to 6, right? This is what I was saying. Now you for changing the level, you do previous is equal to previous left, right? This way you do it. And this was the approach, that was the third approach using recursion. So basically if the roots left is existing, so I mark my roots left next is equal to root right, and if the roots next is also existing, so that means I am at not the last node of the current level, so that means I'll mark its right child to the right child's next to the next node on that particular level with the left child. Okay, so that is how you can do this. So this was the problem. It has been asked in a lot of good companies. So this problem also has this problem is special because in this you are having a perfect binary tree, but there is a problem similar name, it is part 2 of this problem, follow-up problem, that is populating next right pointer in each node 2. So you can try out that problem, and in case you find any difficulty with that problem, so you can mention that in the comments and I'll solve your doubts for that. Also let me know how did you like the explanation for this video, for this problem. Like I brought 3 approaches, all the 3 approaches, you can find all the 3 approaches of this particular problem in the description of this video. All the codes have been accepted and I have cross-checked them, verified them using a dry run. So this was it, and let's meet tomorrow with the problem of the day. Also make sure after this stream is over, and if you are watching recording, so make sure to comment like how many DSA or competitive programming questions you have done. Also I'm planning to bring the binary search series very soon, maybe tomorrow or maybe on the New Year's, maybe as a gift for you.